Understanding ocean currents. Ocean currents are large-scale movements of seawater that flow through the world's oceans. These currents are like vast rivers in the sea, moving water around the globe and playing a crucial role in regulating the Earth's climate, distributing nutrients, and supporting marine life. Understanding what drives these currents is key to comprehending their impact on our planet. The role of wind in surface currents. Wind is one of the primary forces that cause ocean currents to move. Surface currents, which occur in the upper 400 meters of the ocean, are driven by the wind blowing across the water's surface. The trade winds, westerlies, and polar easterlies push the water, creating currents that can travel across entire ocean basins. These winds also contribute to the formation of major currents like the Gulf Stream and the Kuroshio Current. The influence of Earth's rotation. The rotation of the Earth, known as the Coriolis effect, significantly influences the direction of ocean currents. As the Earth rotates, it causes moving water to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection shapes the circular patterns of currents known as gyres, which dominate the movement of water in the world's oceans. Temperature and salinity differences. Temperature and salinity differences in seawater also drive ocean currents, particularly those that occur in deeper layers of the ocean. Warmer, less dense water tends to rise, while colder, denser water sinks. Similarly, water with higher salinity is denser and will sink below less salty water. This process, known as thermohaline circulation, creates a global conveyor belt of deep ocean currents that move water between the poles and the equator. The impact of ocean basin shape. The shape and depth of ocean basins influence the direction and speed of currents. As water flows around the continents, it is funneled through narrower passages and redirected along coastlines, creating boundary currents. These currents, such as the East Australian Current, can be particularly strong and have a significant impact on the climate and marine ecosystems along the coasts. Tidal forces and their effects. Tidal forces, generated by the gravitational pull of the Moon and the Sun, also contribute to the movement of ocean currents. These forces create tidal currents, which are most noticeable in coastal areas and shallow seas. Tidal currents help mix ocean waters, bringing nutrients from the deep to the surface and supporting the productivity of marine life. The global conveyor belt. The global conveyor belt is a continuous, deep water current that circulates around the planet, driven by thermohaline circulation. This system moves warm water from the tropics to the poles and cold water back towards the equator, playing a critical role in regulating global climate patterns. The conveyor belt helps distribute heat around the planet, influencing weather systems and oceanic conditions. Climate change and ocean currents. Climate change is affecting the movement of ocean currents. Rising global temperatures are altering wind patterns and the distribution of heat in the ocean, which can disrupt existing currents. Additionally, the melting of polar ice is adding fresh water to the ocean, potentially weakening thermohaline circulation and impacting the global conveyor belt. These changes could have significant consequences for global climate and marine ecosystems. The importance of ocean currents. Ocean currents are vital to the Earth's climate system and the health of marine environments. They help distribute heat, regulate weather patterns, and transport nutrients and organisms across vast distances. Understanding the forces that drive these currents is essential for predicting future changes and managing the impacts on both the environment and human societies. Conclusion. Ocean currents are complex systems driven by a combination of wind, Earth's rotation, temperature and salinity differences, and the shape of ocean basins. These currents play a critical role in shaping the Earth's climate, supporting marine life, and connecting the global ocean. As we continue to study and monitor these movements, it becomes clear how integral ocean currents are to the health of our planet.